So, in this video, I'm going to talk about a few theorems. And it hurts me to do this, but I'm not going to prove the theorems because I just don't have the time in this video. I want to make this video short enough that you can digest it, not so long that you zone out. Which you might zone out anyways, that's, But I'm going to try to keep it engaging and try to keep it short enough for you to think about. Maybe one day I'll get around to posting solutions or worked out, these theorems worked out. But I really would encourage you to try to prove these theorems yourself, because my geometry teacher in college would say, you need to believe it in order to use it. If you don't believe that these things are true, using them is so much harder. So if you can build the intuition to believe that the congruent supplements, the congruent complements theorems are true, then that will go so far. So I really would recommend try to prove these on your own. Like I said, maybe one day I'll get some proofs up. We'll see. Okay, so the congruent supplements theorem. The congruent supplements theorem. If two angles are supplementary to the same angles, then the two angles are congruent. And we've done some proofs in the past where this would make it so much easier, right? So, it would make it so much easier if we just could say, okay, this angle 1 is supplementary to angle 2. Angle 1 is supplementary to angle 3. So angles 2 and 3 are congruent. It's almost like the transitive property for supplementary angles. So let's see. We could say this. Sure. The measure, we're not going to say the measure. Angle 1 and angle 2 are supplementary. And then there's two different ways you could take this. Either you could say, I'm going to kind of branch off. Oh, well, so this is the first one. Angle 1 and angle 2 are angle 1 and angle 3 are supplementary. So then angle 2 is congruent to angle 3. Now the second part, okay, two angles are supplementary to congruent angles. So here I might say angle 4 and angle 5 are congruent. Sorry, not congruent, getting ahead of myself. Supplementary. Angle 4 is congruent to angle 6. Angle 6 and angle 7 are supplementary. So then, because I know that angle 4 and angle 6 are congruent, and I know that angle 4 and angle 5 are supplementary, and angle 6 and angle 7 are supplementary, then I can say angle 5 is congruent to angle 7. And it could work in reverse as well. But that's kind of the two options that when we're talking about the congruent supplements theorem. If you know the angles are congruent and you've got supplementary angles, then the other angles are congruent, the other pair of angles is congruent. Or if you know one is supplementary to 2, one is supplementary to 3, then 2 and 3 are congruent. Again, this is kind of like the transitive property for congruent, for supplementary angles. Okay. Congruent complements theorem, hopefully you're like, oh, I know what that's going to be about. Right? And we'll do the same thing. Maybe I can make it a little cleaner this time. If I have angle 1 and angle 2 are complementary. Angle 1 and angle 3 are complementary. Well, then angle 2 is congruent to angle 3. And two congruent angles, well, all right, let's try this. Angle 4 is congruent, is complementary to angle 5. And well, let's do the other way. Angle 5 is congruent to angle 6. And then I know that angle 6 is complementary to angle 7. Well then, because 5 is congruent to 6, 6 is complementary to 7, 4 is complementary to 5, well, kind of we have almost a line here, right? So then 4 and 7, angle 4 is congruent to angle 7. Because 4 is complementary to 5, 5 is congruent to 6, and 6 is complementary to 7. That means 4 and 7 have to be the same angle. Okay, we've got one more theorem. The right angle congruence theorem. And let me just say this. I'm okay. I don't know, and some other teachers might hit me for this. I'm okay if you call this the CST, the congruent supplements theorem. I'm okay if you call this the CCT, congruent complements theorem. That's fine. You don't have to write it all out. We're in the same space, so we know what we're talking about, all right? Down the line, that might not fly, but for me, it totally does. Okay, the right angle congruence theorem. Yeah, and I don't know. There's maybe not an easy way to short this. You could call it the ract. I'm not sure I love that, but it is what it is. Okay, if two angles are right angles, then they're congruent. This is pretty self-explanatory, but it's nice because in the past, this is a brief aside, but in the past, you would have had to do something like this. If you knew that angle 1 was a right angle and angle 2 was a right angle, whatever. I mean, my tenses are kind of weird here. Angle 1 is, okay, angle 1's a right angle, angle 2's a right angle. All right. Well, then you would have to say, okay, by definition of a right angle, the measure of angle 1 is 90. By definition of a right angle, the measure of angle 2 is 90. And then by transitive, the measure of angle 1 is equal to the measure of angle 2. So, I don't know, this would be def right angle. And then you'd have to use transitive of equality. And then by using the definition of congruent angles, then you could say angle 1 is congruent to angle 2. Here, well, I guess I just proved it for you. Well, I couldn't help myself. So if two angles are right angles, well, all I'm saying is that angle 1 is a right angle. Angle 2 is a right angle. So we know that angle 1 is congruent to angle 2 just by the right angle congruence theorem. That's it. After that, you're done. And that's it. That's all of these different theorems, and we're going to use them in so many different ways. And the nice thing about these theorems is if you don't remember it, then you can always prove your way through it. But I really would recommend to actually try to prove these. I guess I proved the right angle congruence theorem for you. I just got carried away. I don't know. I saw red and it just, I don't even know what happened. But maybe try to prove the congruent complement and congruent supplements theorem. I think that that's really useful for you to believe what you're using in this class. If you believe it, it will become so much easier for you to apply it. And that's your that's your philosophy lesson of the day. I'll see you next time.